Hello everyone. So our today's topic is resonance. Let me tell you what resonance is. Resonance is a phenomena in which you study the delocalization of pi electron in a conjugated system. That is the delocalization of pi electrons, pi electrons only, not sigma electrons, pi electrons in a conjugated system. What conjugated systems are? Molecules which have alternate single, double bonds are called as conjugated system. See, this is your conjugated system, single bond, double bond, and you can consider this also a conjugated systems. Double, single, double, single. This is also conjugated system. Now, what resonance is? Resonance is delocalization of pi electrons. Delocalization means movement, shifting of pi electrons in a conjugated system. Let me tell you. Pi electrons are continuously moving in a conjugated system. The most common example of a conjugated system is your benzene ring. Now here your pi electrons are continuously moving. What do you understand by delocalization of electrons? Delocalized electrons are those electrons which are loosely held are known as delocalized electrons, or pi bonds which are loosely held so they can move freely in a molecule. Because of that only delocalization is possible. Or pi bonds which are continuously moving electrons are loosely held so Okay. Now let me tell you the definition of resonance. And a single Lewis structure cannot explain all the properties of a molecule, then we use more than one structure to explain all the properties of a molecules. This phenomena is known as resonance. Molecule, then we use more than one structure to explain all its properties. This phenomena is called resonance, and the structures are all the structures which will explain the properties. So the basic definition of resonance is when a single Lewis structure cannot explain all the properties of a molecule, then we use more than one structure to explain all the properties, is called as resonance, and the structures are called as resonating structures or canonical forms. Resonating structures or canonical forms. Resonance we show by a double-headed arrow. Now, okay, consider an example of O3 molecule. This is your O3 molecule. How the pi electrons can move? Your pi electrons will move like this. Here will be your double bond, it's your negative charge. This is an example of resonance in your O3 molecule. How will be your resonance hybrid form? Okay, your resonance hybrid will be where we show the delocalization, then it is called as your resonance hybrid. This is your resonance hybrid. Hope you all understand what I'm trying to say. With O3 molecule, you can understand the delocalization or the shifting of pi electrons within the molecule only. Okay, let me show you some more examples of resonance. Just like By double-headed arrow, you will show resonating structures. Now, how this will shift the pi electrons? These will shift like this. Here, oxygen accepted the pi electron, so here will be your negative charge, and it will be double bond. Nitrogen has a lone pair of electron. This is your shifting of electrons or shifting of pi electrons. Okay, so tomorrow we will study types of resonance conditions to show resonance and the stability